Can AI adoption in manufacturing succeed without a category-defining platform? Let's explore this question. In a typical discovery meeting with any manufacturing or power-generating potential client, generally, TAAIB likes to ask some targeted questions to expose the functional gaps in most plant operations' current software stack. Therefore, before addressing new technology, TAAIB first seeks to understand a plant's operations' current toolkit. One of the first targeted questions is this. When a new operator joins the floor, what platforms or solutions does the plant currently use to train new operators on the end-to-end manufacturing process? Not just their specific station, but the whole flow from raw material to finished goods. The typical response to this first question is this.
Honestly, nothing shows the full manufacturing line from a systems perspective. Furthermore, we use a mix of SOP binders, shadowing experienced operators, and maybe some OEM-specific human-machine interface training modules. But nothing shows them the whole line from a systems perspective. If a senior operator is out, that tribal knowledge walks out the door.
Tribal knowledge is not a platform. In most cases, operator onboarding depends on people's memory. That is one of the gaps. Documentation exists, but operating reality is a different story. That is why a vCPPS is needed. It turns the operating process into a visual, testable operating reality through careful scaffolding. The second question TAAIB generally asks is usually directed at controls engineers. The question is this. What platforms do you have that allow the plant to test operational logic and see upstream and downstream impacts without requiring a massive OT/IT integration project or bringing in the OEM for every little change? The response from controls engineers is generally as follows.
We have our OEM tools, but they are locked to specific machines. If an engineer wants to test a logic change that affects the whole line, they usually have to do it during a maintenance window on the live line, or build a clumsy spreadsheet model. We don't have a safe, plant-wide sandbox for logic testing.
The point is this. Machine-level tools do not answer line-level consequences. What happens upstream and downstream of a machine's movement does matter. There are multiple and diverse suppliers on the market today, with distributed control systems, MES, SCADA, historians, ERP, and other silo-driven, dashboard-oriented solutions. Each do offer some flavour of AI biased towards their own solutions. Therefore, what are generally true in today's manufacturing and power-generating plants environments are the following 3 points. 1. There are systems of record for what happened. 2. There are systems of control for what is happening. 3. However, generally, there is not present a governed environment to model what will happen before it touches the physical plant. Additionally, one should not confuse virtual commissioning of a machine using the OEM-supplied system as the same as understanding end-to-end plant operating reality. There is a distinct difference, and for manufacturing and power-generating plants, adopting and deploying AI, this distinction is important. Let's look at the executive gap around AI without plant reality proof. The related question TAAIB generally asks is this. From a leadership perspective, what platforms allow management to understand the actual benefits of adopting AI, grounded in your plant's messy operating realities, rather than just vendor slide decks and walled demos? The typical response is this.
Nothing. We see the AI hype, but we don't have a way to simulate how an AI recommendation would actually play out against our maintenance windows, spare parts constraints, and shift variations before we commit capital or risk downtime.
So you have systems of record for what happened and systems of control for what is happening. but you don't have a governed environment to model what will happen before it touches the physical plant. Adopting AI, the approach should be prove first that AI will work before ripping or replacing assets and/or without committing heavy capex spend. Although there is recognition of the gap just exposed, defense through skepticisms undoubtedly kick in. TAAIB acknowledges that the skepticism is valid and treats skepticism as a design requirement. Here is one of the skepticisms generally expressed.
If TAAIB vCPPS platform is not plugged into our live PLCs and data streams on day one, is it not just a cartoon? How is it real? How can a disconnected model possibly reflect our actual plant reality?
TAAIB agrees that a disconnected model may be useless. But here's the reality. Live data on day one can actually be much more dangerous. A flight simulator to a pilot's training is a faithful model of aircraft behavior and pilot tasking. One just doesn't put a pilot to fly a plane without the pilot first having flight simulator training. One should be able to take a similar approach with AI adoption and deployment in manufacturing operations.
I see where you're going. You're pitching me on a digital twin.
No, TAAIB is speaking about vCPPS and the creep, walk, run approach. Life data is often full of noisy sensors, missing tags, and bad data habits. Plug an AI directly into live PLCs on day one. The AI learns the plant's operation flaws, not its potential. Data should be validated first against plant reality. That is why TAAIB starts virtual first to map constraints, operator workarounds, and safety interlocks. With TAAIB vCPPS platform, one builds the logical operating reality before introducing the noise of live telemetry. It allows the plant operations to be simulated first, so crash the vCPPS, not the physical line.
Okay, on transition, you mentioned machine I/O switch that lets us go from virtual to physical seamlessly. If this is so revolutionary, why don't the likes of Siemens or Rockwell offer this? Are you selling something the giants can't even build?
No, it's not that the giants don't have the engineering talent. It's that they are trapped by their own history. Their software architectures are old, built on proprietary backplanes designed to sell physical hardware lock-in. Furthermore, they generally focus on virtual commissioning, where they test, does the machine move correctly? TAAIB vCPPS platform focuses on operational reality, testing if a machine's movement will break the production schedule or violate a maintenance window. In that sense, the giants do not build what TAAIB offers, otherwise they would need to abandon legacy foundations. TAAIB offers a neutral orchestration layer. It doesn't have a hardware agenda.
But we already spend millions on MES, SCADA, and historians. Why do we need TAAIB vCPPS platform? Aren't we just adding another layer of software?
We aren't here to replace them. We are here to orchestrate them. Your MES tells you what happened. Your SCADA tells you what is happening. Your historian is just a massive graveyard of timestamps. However, TAAIB vCPPS platform tells you what will happen if you change a rule, a schedule, or a recipe. It is the sandbox to test decisions before MES and SCADA systems execute them. It makes your existing stack explainable and testable.
All right, but here is the biggest fear. If we start using this platform for AI to optimize the line, how do we know it won't recommend something that violates a critical safety interlock or schedules maintenance when we don't have the spare parts?
That is exactly why TAAIB doesn't throw raw data at a black box algorithm. TAAIB's creep, walk, run approach is to use governed vCPPS with no-code PLC logics and behavior profiles. Most AI systems optimize for pure throughput. TAAIB vCPPS platform constrains AI to simulate decisions against safety interlocks, spare parts constraints, and maintenance windows in the virtual world first. If the platform's AI's recommendation breaks the virtual plant, it never reaches the physical plant. The right to scale is earned by first proving operational fit in the vCPPS.
So, let me get this right. What TAAIB is saying is, we don't have to rip and replace current stack, and we don't have to risk the live line to prove AI works.
Exactly. In the creep phase, start with a no-touch simulation to capture operating reality. In the walk phase, address cross-functional validation. In the run phase, only run physical connectivity when the evidence justifies it. TAAIB isn't selling a cartoon with its TAAIB-vCPPS platform. It is selling a governed operating reality layer that current systems on the market today are missing.
Ah, we get it now. TAAIB is offering a new category-defining platform as a virtual cyber-physical production system, vCPPS.
You are correct. There is a distinction between a CPPS and a vCPPS. TAAIB vCPPS platform creates virtual CPPS for AI-governed manufacturing. Traditional digital twins and CPPS begin with connected physical plants. TAAIB vCPPS platform begins with a virtual environment of defined asset administration shell, AAS, of sensors, actuators, PLC-like logic, behavior profiles, and SKUs.
Tell us more about TAAIB CPPS platform. What is distinctly different in its technology and approach to successful AI adoption in plant operations?
Good question. Distinction 1. TAAIB vCPPS platform has patent-pending AI technology that combines GRASP algorithm with reinforcement learning to steer operations to more good days than bad days. Consider this as TAAIB vCPPS platform capturing the best of tribal knowledge and making it intelligently available to all for governed AI.
What do you mean by governed AI, and is that another distinction of the platform?
Governed AI could be considered as distinction 2. TAAIB vCPPS platform grounds Gen AI across a plant's specific asset structure, telemetry, transactions, descriptive AI, and documents. These 5 sources protect against AI hallucination.
We do have one final question. Is there something of note with the V in your TAAIB vCPPS platform?
The V provides distinction 3. It is the risk breakthrough. In phases 1 and 2 of TAAIB's creep, walk, run AI adoption approach, the physical plant is made virtual in a no-touch scaffolding with virtual machines, sensors, actuators to simulate plant operations that produces synthetic data. In the run phase, the virtual plant is connected to the real plant in read-only mode. These 3 distinctions make TAAIB vCPPS platform as category defining because it changes AI adoption sequence. TAAIB vCPPS platform provides the governed environment where AI proves itself against production reality before the plant is asked to trust it.
We get it. TAAIB vCPPS platform successfully addresses our fears that AI may break equipment, schedules, safety logic, or maintenance plans.
Going back to the original question, can AI adoption in manufacturing succeed with a category-defining platform? The answer is yes, and TAAIB vCPPS platform is the category-defining platform a plant needs today.